Well, good afternoon, grade 11s. I'm sure you've heard that school is not going to be resuming this year. And so, yeah, it looks like we'll be doing this for the rest of the semester, but that's okay. Okay, we'll see what happens in September. I think it's going to be a really interesting school year for you next year. I know, like for us, it's going to be probably some interesting changes happening just until they develop a vaccine anyway. But we'll see what happens. At least you're not graduating this year because that I feel sorry for the grads. But all right, so listen, we're going to start this unit and we're going to see how it goes. I think we'll kind of get through this before the end of the semester, and hopefully we'll go through the sound unit too, which normally we do independently, but I think I'll just do it with you. So anyway, we're going to start with this, and for this week, we had a couple of lessons this week. And so I'm just going to go through it quickly. And I'm going to post another lesson tomorrow, which is a bit unusual. Usually I just do sort of one lesson and then a worksheet or something like that. But this one's review of grade 9, so it's really easy. All right, so the last unit, or one of the, maybe the last unit we'll do. We'll see if we get to the sound unit. But anyway, this unit, electricity and magnetism. Okay, so we're going to start with electricity. And just a review of a couple things from grade 9. Okay. We use something called the electron theory to explain electricity. Okay, as you know, everything in the universe is made up of matter. Okay, well, at least there's matter and energy. Okay, but the stuff of the universe is made of matter. Okay, so it has mass and so on. Well, matter is made up of particles called atoms, and atoms in turn are made up of smaller particles called protons, neutrons, and electrons. Okay. Yeah, so protons and neutrons are actually a class of particles that are called baryons. And baryons are located in the nucleus of atoms. Okay. The proton has a positive charge, so it has an electrical field around it. It has a positive charge. And the neutron is neutral, and that's why we give it that name, neutron, right? Okay, electrons are small, they're light compared to the baryons. Okay, they're actually a type of particle called leptons. Okay, but electrons are floating around the nucleus. Okay, and they're kind of hovering around there, and they are in these orbital configurations that you'll learn about in chemistry class. But for us, what's important is, for electricity at least, that they're loosely held. Okay, so electrons are loosely held particles, and that varies from atom to atom. Like nonmetals have a stronger hold on their electrons compared to metals. Okay, that's because they have a higher affinity for electrons. They don't want to let them go. But metals, on the other hand, have a relatively low affinity for electrons. And therefore, there's something called the C model when like electrons sort of float around in a good conductor, the valence electrons, and then they're easily pushed around. Okay, so we have something called electron theory to explain static electricity and various electrical effects. So here I have a balloon, okay, and I've got this balloon, and if you were with me in grade 9, we would have gone through this app already. But if you were not with me in grade 9, then maybe you're looking at this for the first time, but it's pretty straightforward. The balloon is neutral. It has, you know, 4 positives and 4 negatives. Now, in reality, it would have trillions of positive charges. Every atom has many protons in it, right? And then it would also have trillions of negative charges, but overall neutral, okay? So equal numbers of positives and negative charge make something neutral. Now, the sweater over here also has positive and negative charge. It is also neutral, and the wall over here on this side is also neutral, having equal numbers of positive and negative charges. Now, none of these things are good conductors of electricity. They kind of hold on to their electrons fairly well. Now, the protons in solid objects are not movable. They're in the nucleus, and therefore they cannot be added or subtracted to a solid object. However, the electrons, on the other hand, take a look. The balloon has a neutral charge, but it has a high affinity for electrons. So when I stick it close to the sweater and just sort of rub it around the sweater there, what it does is it picks up electrons from the sweater and becomes now negatively charged because it has an excess of electrons. Notice its positive charges have not gone anywhere. They're fixed in the nucleus. They don't move. Okay. Now, the sweater has lost electrons, and that's why it has a positive charge. Now, the positive charges are important. Okay. They're just sitting there. They're sort of spectators, but they do attract electrons. Okay, so now the balloon and the sweater are oppositely charged, and if I just let this go, you'll see that the balloon is pulled over to the sweater. Okay, now if I bring the balloon close to the wall, look what happens to the negative charges there. They get pushed. Okay, they get pushed back, and that's because they are repelled by the negative balloon. Now that makes the wall that's close to the balloon slightly positive. And that's why balloons will stick to a neutral wall. Now the wall stays neutral the entire time, okay? But we see this is called charging by induction. When we bring an object close and pushes the electrons, okay, it either draws them in the case of a positive charge or pushes them away in the case of a negative charge. So here it's pushing them away, creating a net positive charge just at the wall close to the balloon, and that's why the balloon sticks to it, okay? So anyway, this is electron theory, and I'm just showing you an example of how this works. So now what I'm going to do is I'm going to make a second video where I give you notes on this, and then there's a short assignment, and then that's it for today. Okay? All right.